What if you could produce clean drinking water right out of thin air and without using electricity? That's what one Arizona-based startup is trying to do, using a combination of solar energy, material science, and data. Is this the next level of drinking water? This is Zero Mass Water. It's a water startup operating out of an old car dealership in Scottsdale, Arizona. Zero Mass is building and selling solar-powered panels that harvest drinking water, called Source. The panels have been up and running in specific locations over the past couple years, but Source just became more widely available.
At the very highest level, we take sunlight and air and we produce water. And so as you drill into that, the air part of that equation is applying air into materials that like water. So in the same way when you leave a lid off of a sugar bowl, the sugar gets a little clumpy. That's because that sugar really likes water in the air.
I visited Zero Mass at their headquarters to check out their panels and, of course, to taste the water.
And where is this water coming from?
So the panels that produce this water are on the roof. So we're taking the water vapor out of the air, concentrating it in the panels, and then we're dispensing it to the tap.
It tastes nice and clean.
It's good, isn't it?
Yeah, I had some tap water last night that didn't taste quite like this.
Okay, so to say they pull water from the air is technically accurate, but really it's a multi-step system. The Zero Mass panels look like regular solar panels, but the middle strip is the only part that is standard photovoltaic technology. That part drives the fans and the communications inside the unit. On either side of that strip is a proprietary porous material, one that generates heat. A separate proprietary material inside the panel absorbs moisture from the air. Then the panel uses sunlight to take the water back out of those materials and produce a process that's not dissimilar from dew forming on grass. Basically, when warm air hits a surface colder than itself. And then the water ends up in a 30-liter reservoir where it's mineralized and pH balanced. And at that point, it's drinkable.
Let's say there's an emergency situation, like with the recent hurricane in Puerto Rico. How quickly can you get one of these set up?
So the three of us could install two of these in probably an hour. And so it actually turns out that the thing that takes the longest in putting these in is moving that line down to the sink or to the refrigerator.
While I was able to see the Zero Mass panels and taste the water, I didn't have much visibility into how the water actually runs from the reservoir to a faucet. I was, however, able to see the company's network operations center.
We call it the NOC for short. Every panel that we've ever deployed is communicating with the server we have here.
Robinson also said that each panel has a circuit board that runs an algorithm, so it can adjust itself to maximize water output. On average, each panel is supposed to produce 5 liters of water per day.
But it is safe to assume that if you're in a less humid climate or a more dry climate, that your water output could be less.
Yes.
But here is probably very different from here in that's the Philippines, right?
Yep. The two things that affect the amount of water we produce are the humidity in the atmosphere and the amount of solar energy that's available.
Still, he says that Zero Mass panels are absolutely able to make water in the desert, even in a place as dry as Arizona. There's no doubt that a lack of access to clean water is a big problem for a lot of people. According to the United Nations, water scarcity affects more than 40% of the global population.
What would you say is the biggest water problem we have around the globe right now? Is it scarcity? Is it quality? Is it access?
I would say it's really all of the above. That would be the right answer. The number of people who die from waterborne diseases is enormous. It exceeds 1 million deaths per year.
Dr. Ashok Gadgil is a kind of legend when it comes to socially beneficial technologies, especially in the developing world. He's won numerous awards, including an induction into the National Inventors Hall of Fame. And back in the 90s, he developed a product that uses UV light to disinfect water. He says that changes in climate patterns, the explosion in urban populations, and rising incomes are setting us up for a serious water crisis.
This century is going to be an extraordinary crisis, that the groundwater which we relied on as if it was there in indefinitely large quantities is not, of course, there that way. And we have to drill deeper and deeper, and we are extracting now water that some of my geochemist friends tell me is 10,000 years old, that is being pulled out of the ground to be used, because that's the rate of replenishment is minuscule compared to the rate of withdrawal.
So is Zero Mass going to replace groundwater as a primary source? Is it going to help people with little to no access to clean water? Or is it just for people who buy a lot of bottled water? Cody Friesen, the CEO, says all of the above.
This takes us from a position of water scarcity to a position of water abundance for every person. And it's a profound thing to say, and I recognize it sounds profound, but this technology entitles us to be aspirational because of the fact that we can say, okay, yep, there's Syrian refugee issues in northern Lebanon, let's go there. Yep, Maria hit Puerto Rico, yep, let's go there. Hey, there's issues in Flint, let's go there. Hey, by the way, you're buying bottled water in Berkeley, let's displace that. Same in Oakland, same in Scottsdale.
There is still the cost to consider. Each panel costs $2,000 plus a $500 installation fee, so $4,500 total for a 2-panel array. So far, Zero Mass says hundreds of panels have been set up in 8 countries around the world. For people in developed markets, that means they're either early testers or they're paying out of pocket. In emergency situations or places where there's a lack of funding, the company is relying on donors, NGOs, or multilateral institutions.
The fact that it's totally independent of any infrastructure, no wire, no pipe or anything, the fact that we can just put this anywhere changes your lives.
There's no doubt Zero Mass is working hard on an innovative way for people to have access to clean water without electricity or sophisticated plumbing. Not surprisingly, others are working on solutions like this too. The question then doesn't seem to be whether it's too good to be true. It's whether harvesting water from the air is the most sustainable, most cost-effective solution for clean water. While Dr. Gadgil declined to comment on Zero Mass specifically, he said the method of harvesting water from the air wouldn't be his first choice.
Pulling water from moisture, condensing water from moisture in the air is viable if I was on a desert island. I had lots of money and there was no other source of fresh water and I was going to die. Then the value of my life is what is now pitted against the cost of that water.
Instead, he says conserving water and recycling water, like the stuff we flush down the toilet every day, are still more cost-effective than harvesting new water.
We need to do both, but we should do whatever is cheaper and least damaging to the environment. In almost all cases, reusing the water seems to be the cheaper way to go. Similarly, conserving water seems to be a cheaper way to go before you start harvesting it from the air.
In the world of water, there may be different interpretations of sustainability and varying approaches to how to just get clean water to more people. For Zero Mass, the company says the goal is to get to the point where the idea of water from thin air is just a part of people's everyday conversations.
If you're at a cocktail party and you say, oh, I've got solar on my roof, people think, oh, electricity. To in a small number of years, people saying, oh, you have solar on your roof, are you talking about electricity or water? Yeah, let's go up to the roof and check out our array up there.
Okay. And Mike's coming with us, right? Is it Mike coming with us?
I think Mike was supposed to come with us.
Yeah, Mike's coming with us.
Oh, I'm supposed to? Sorry, I was getting mixed
Why don't
signals.
we all just we can all enter from around the corner.
Let's do that.
And that way it's